Okay, now let's get into the rules that I was talking about earlier. So, um, if we're given a function y is equal to u times v, where u and v are two different functions. So let's say an example would be like x minus 2, 2x plus 3. So two different functions being times together. Um, then we can use a rule to differentiate this, and that is called the product rule. So y dash will be equal to v times u dash, so the original v times the derivative of the u plus the original u times the derivative of v. Or it's given this notation, which is the exact same equation, just written in a different method. And this is the way that the formula sheet writes it. But I personally, to this day, use this one because it just looks a bit nicer, right? But let's use an example because both of these, let's face it, look absolutely disgusting. Oh, okay, we don't have an example. Let me write an example then. My question to you guys is y is equal to, let's use my example from before. X plus 1, 2x plus 3. That's my example. I'm going to give you, actually, no, I'm going to actually show you how to do it because it's a bit of a tricky rule if I do say so myself. I'm going to define my u and my v. So u will just be my first function because I'm not fancy like that. So it's equal to x plus 1. U dash will be the derivative of u, right? So it will just be 1. V will be equal to 2x plus 3. V dash will be equal to just 2. Now, obviously, for this kind of example, you can use FOIL and just expand, but there will be many examples that you'll pass where expansion won't really help, and you'll still have um, two separate functions being times together. So it's really important that you actually learn how to use this rule. So let's follow the y dash rule. So it'll be v times u dash. So this times that. So it'll be 1 times 2x plus 3 plus u times v dash. So like that. So it'll be 2 times x plus 1, which gets me to 2x plus 3 plus 2x plus 2. So my final answer is 4x plus 5. That is my final derivative. Okay? Awesome. Okay. Now let's go into the chain rule. Statistically, the chain rule is the most like the pretty much the bane of most HSC students' existence. It's the one that people most get confused on, and I'm not sure why, but as people head towards the HSC, they kind of just forget this rule exists. So my mission today is to make it as nice for you guys to understand as I possibly can. Okay. But basically, it's when we have a whole function to the power of n. So instead of it just being like x to the power of n, it's going to be some disgusting function that we'll call f of x, right? All to the power of n. Okay. So the derivative of that, so d dx, we'll take the function out the front just like we do for the simple differentiation. So it'll be n times f of x to the power of n minus 1. So far it's like exactly like our x to the n kind of formula, but in bigger version. But the next thing is something that we need to do that's not in the x version. And that is we also need to times by the derivative of what's inside this function. So we're going to also times by f dash of x, which gets us to, n f dash of x, f of x to the power of n minus 1. Okay, I think there's an example in the next slide. Yeah, we'll use that example in a sec. Let's do this one first. So my question for you guys is f of x Oh, we'll just go y to make life easier. Y is equal to 2x squared plus 1 to the power of 4. I'm going to give you a second to try this one on your own because it is quite similar to our x to the power of n1, and I have a feeling you guys will be able to do this on your own. So I'll give you a minute. Also, I probably should have told you in the start of the lecture, the reason why I'm barely looking at the camera is because my computer's over, like I've got type my writing pad down here and my screen like over here. So I like never look at the camera. Sorry, I've got an external camera on. So I apologize if I'm like barely making eye contact with you guys. But yeah, let me get started with the question. So let's define our f of x. F of x, actually, let me do it in a different color so that we're not confusing it with my like explanation up the top. We'll go back to yellow. So f of x is equal to 2x squared plus 1. So my f dash of x, using our basic differential rule, gets me to 4x. Okay? So y dash will be equal to n, which is the power, so 4 times f dash of x, so 4x, times f of x to the power of n minus 1. So the original f of x, so 2x squared plus 1 to the power of 3. So my final answer is 16x, 2x squared plus 1 to the power of 3. Okay? I hope that made sense. We'll go through another example real soon as well. Okay, so the chain rule is used for composite functions. So I kind of went through this already, but it's also known as a function of a function rule, okay? Which I think there might be another explanation. Never mind, no explanation. I'm going to give you a second to do this question on your own because it's simpler than the one that I went through before. And I also believe that you guys can do this on your own. While you guys are going through that, I actually want to explain to you that the x to the power of n rule still follows the chain rule example. So let's do x squared. Okay, so y is equal to x squared. I'm going to set my f of x to just be, what's underneath the power. So it'll just be x. So f dash of x is just equal to 1. So doing my like plain example, my y dash will be equal to bring the power, not the flower, to the front. So 2 times f dash of x, so 1 times f of x, so just x to the power of 2 minus 1, so 1, which leaves me with just 2x. So even the simpler rule is just the chain rule again, but a little bit nicely done because x's derivative is just 1. Okay, and that will nicely lead us into the explanation for this question. Differentiate y is equal to x minus 4 to the power of 10. Let's define our f of x. So f of x is equal to x minus 4. So f dash of x is equal to just 1. Okay, so let's do our final y dash, which will be equal to n, so the power, which is 10, times f dash of x, which will just be 1, times f of x, x minus 4, to the power of n minus 1, so 10 minus 1, which gets me to 10 x minus 4 to the power of 9. So see, it's a disgusting looking rule, but honestly, it's not that bad, right? It doesn't, I think it's very much overhyped in that, in the negative way. It's very much, I can't say underhyped. I don't know what the negative version of overhyped is. But yes, it is that word. Okay, now I have another question for you, which is also the chain rule. So y is equal to 2x squared plus 5x minus 3. I'm going to give you a minute to do this one on your own because it's a little bit more tricky, but it's actually the exact same thing. So take a sec. Okay, you'll probably need a bit more time, but just so that we can get everything done in time, I'm going to get you to pause the video if you need some more time and then unpause to take a look at my working, okay? So let's go through this question. So let's define our f of x, which is whatever's inside the brackets, right? So x squared plus 5x minus 3. So we have f dash of x will be equal to 2x plus 5. All right, now let's actually do our y dash. So going back to our original rule, when I said that we have a constant times a function, the constant itself, the coefficient, isn't being times. So the 2, it just chills out the front. And we're going to times that by our n, so 4, times f dash of x, so 2x plus 5, times our f of x, so x squared plus 5x minus 3, all to the power of n minus 1, so 4 minus 1, which will be equal to 8, 2x plus 5, x squared plus 5x minus 3 to the power of 3. And that's my final answer. I suppose if you wanted, you could expand out the brackets for this. But honestly, if you're leaving things in simplest form, this is as simple as it gets. So that is what the HSC would want you to do. Okay? All right. Let's see if there's another question. Because if I'm going to get you guys to do that one in a sec, I want to write another question for you guys though. So my question for you is differentiate the square root of x cubed plus 2x plus 1. Okay? I'll give you a sec to do it. Yeah, okay, I'll give you 30 more seconds and then I'll get started. Okay, shall we get started? I think yes. So I'm going to actually rewrite this. So most of you guys would know a little bit of your index laws from year 10. Um, so this can be rewritten as x cubed plus 2x plus 1 all to the power of a half. Now from here, I think you guys would be able to solve it. So f of x is equal to x cubed plus 2x plus 1. So f dash of x is equal to 3x plus 2. So my y dash will be equal to my n, which is a half, times my f dash of x, 3x plus 2. Let me rewrite that because that's gross. 3x plus 2 times my f of x, x cubed plus 2x plus 1, all to the power of n minus 1. So a half minus 1, which gets me to a half 3x plus 2, x cubed plus 2x plus 1 to the power of negative a half. Now, if I'm going to write this in my best mathematical manners, because they didn't give me to the power of a half and stuff like that, they gave me in my square root form. So I'm going to do the same thing. So negative a half power is basically 1 on root blah, blah, blah. So the way that this can be rewritten is, a half times, we'll go like this so that I can visualize it a bit better for you guys. So it's 3x plus 2 on 2 times 1 on root x cubed plus 2x plus 1. Okay, so my final answer will be 3x plus 2 on 2 root x cubed plus 2x plus 1. And that's my final answer, okay? Now I have another question for you guys, and that is to differentiate y is equal to x minus 4 to the power of 5 times x minus 5. Okay? Um, Heads up, this might take a couple of rules from what we've learned already. I'll give you a sec to try this one on your own. Okay, just for the interest of time, I'm going to get you guys to pause this video if you're not yet done and you want to give it a go, and I'm going to get started on the working. Okay? So let's define our two functions. So I actually need to use the product rule and the chain rule for this. The product rule is the big rule that I'll need to be using though. So I'm going to define my two functions, my u and my v. I always pick u to be my first function and v to be my second function, just because it makes a bit more sense, and it'll help you in doing it that way for the quotient rule, which will be the next rule that we learn. Okay, so, oops, why does that keep happening? U is equal to x minus 4 to the power of 5. So u dash, using our chain rule, will be 5 times x minus 4 to the power of 4. And then f dash of x inside the function is just 1, so we don't need to times anything else. Our v will be equal to x plus 5. Our v dash will be equal to 1. So keeping in mind that y dash is equal to u dash v plus v dash u. Let's give this one a go. So it's going to start off with this cross. So it'll be 5, x plus 5, x minus 4 to the power of 4, plus this cross. So 1 times x plus 4 to the power of 5. Okay, now I'm going to take out a common factor of x minus 4, oops, x minus 4 to the power of 4, which leaves me with x minus 4 to the power of 4, which leaves me with 5, x plus 5 plus x minus 4. Okay, so that leaves me with x minus 4 to the power of 4 times 5x plus 25 plus x minus 4, which leaves me with x minus 4 to the power of 4, 6x minus plus 21. Okay, and that's my final answer. I'm actually just going to chuck this out the front because I like my power function to be at the end. That's just my personal preference. You can leave it as the line that I just did though. 6x plus 21 times x minus 4 to the power of 4. And that's my final answer. So it's definitely a little bit more disgusting than the questions that I've given you so far, but it's still achievable, right? I'll give you another example. Here we go. So if f of x is equal to x squared minus 5 times x plus 1 to the power of 7, then find f dash of x. I'm going to give you a minute to try this on your own, okay? Okay. For those of you that would like to try this on your own, I'm going to get you to pause. So I'm going to get started. So let's define our two functions, because as you can see, it's two functions being multiplied together. So I'm going to define my first function to be u. So u is equal to x squared minus 5. U dash, oops, u dash will be equal to, so x squared becomes 2x, negative 5 becomes minus 0. My v is equal to x plus 1 to the power of 7. In this case, my f of x is equal to x plus 1. My f dash of x will be equal to 1. So v dash will be equal to 7 x plus 1 to the power of 6. So my f dash of x, using my equation of y dash is equal to u dash v plus v dash u, gets me to 2x x plus 1 to the power of 7, because I'm timesing by this cross first, and then I'm going to make this cross, which will be plus 7 x squared minus 5 x plus 1 to the power of 6. I'm going to take out a common factor of x plus 1 to the power of 6 like I did last time. And this is just simply because I want to simplify as much as I can. So x plus 1 to the power of 6 times 2x x plus 1 plus 7 x squared minus 5. Okay, simplify further. 2x squared plus 2x plus 7x squared minus 35. X plus 1 to the power of 6. 9x squared plus 2x minus 35. Okay, I'm trying to think, maybe this quadratic could be simplified. So let's take a look and see if it can be simplified. I don't actually know. I haven't done this question before. So what we'll do is You can choose which method suits you best. I think I might just use the quadratic formula. So x is equal to minus b plus minus root b squared minus 4ac on 2a. Okay, that gets me to minus 2 plus minus 4 minus 4 times 9 times negative 35 on 2 times 9. Let's take a look at what the discriminant is. Okay, it's not going to be a nice number because my discriminant is like minus 2 plus minus 35.55 on 18. So I'm actually just going to leave it like this because this is the simplest form that I can get it to.